Good morning, everyone. My name is Melissa Taylor, and I'm a National Product Manager with Graybar. I'd like to welcome you to Graybar's G2 Talk presentation on reducing cost of ownership for surveillance systems. This talk is a part of a webinar series we offer each month for our customers. We have a great discussion lined up for you today, but before I get started, I'd like to cover a few housekeeping items. First of all, if you were one of the first 50 people who joined in on this presentation, you will receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of the screen, you'll see a box for Q&A. Feel free to submit questions throughout the presentation. We'll address as many questions as time permits at the end of the presentation. Lastly, our G2 Talks are all archived on the Graybar.com website, so you'll be able to view this presentation again or recommend it to others. We're happy to team up today with Samsung. As a full-service distributor and security product specialist, Graybar works alongside Samsung to provide the latest in surveillance technology to help businesses maintain high performance while reducing total cost of ownership. You can visit Graybar.com to learn more about our solutions. At this time, I'm happy to introduce today's speaker. We are excited to have Aaron Sachs of Samsung TechWin joining us. Aaron serves as National Training Manager for Security Products at Samsung. He is a subject matter expert on video surveillance and a recognized industry presenter. He also teaches at the acclaimed Samsung IP Institute, where he helps security dealers, consultants, architects, and engineers, as well as end users every day to deploy and maintain analog, hybrid, and IP-based video surveillance systems. Aaron will share information today that's going to help facilitate a better return on your surveillance investment. So without further delay, I will turn things over to Aaron to begin today's presentation. Aaron?
Hi there. Thank you very much. So as we just mentioned, we're going to cover some methods and technologies available out there for reducing the cost of ownership for surveillance systems. A couple quick introduction in some of the things that we'll cover and talk about in this session. First and foremost is when looking at a manufacturer, different systems out there, look for systems that have different lineups available that have the high-end products as well as lower-cost products that have different lineups to suit your needs, and so that you aren't stuck with just one lineup or the other to meet your needs. We'll talk about low light and IR solutions, how that can help significantly save costs with the right types of products. We'll talk about open platform and similar solutions where you can load apps onto cameras to provide custom solutions at significant cost savings. We'll talk about different warranty available for security systems. Typically, a 3-year warranty is very common out there. That can help you over the lifespan of your installation to make sure that you're not paying too much on repairs and failed products out there. And there's lots of investment in research and development. That's you'll see a roadmap of new products, things like 4K, 12-megapixel cameras, ultra-low light cameras out there. Often those can come with a price tag, but a lot of things are available out there now to help reduce that initial cost. And the main thing that we'll talk about today is ways to lower bandwidth, and which will also lower your storage needs, some of the unique features out there to help you implement that. So first and foremost, I like to talk about using firmware embedded devices. Most of us are familiar with IP cameras. They're usually running a version of Linux. They're nice and stable and easy to support. But when you think about your video management platform, your recording platform, a lot of times you use Windows-based appliances. So one significant cost savings is using an NVR, that's a firmware embedded device as well. You have less risks of being attacked, network attacks, DOS attacks, things like that. You don't have to load an operating system on a hard drive. You don't have to worry about the drive failing. So there's lots of ways to save time and money by not needing to constantly worry about security patches, opening ports that aren't needed, and all the different services that are running on a traditional Windows server. That a typical NVR firmware embedded device is designed for 24/7 operation. That you plug it in and it's going to work. It's also important to look at end-to-end solutions when possible, to look at a single manufacturer. That often you can have ways to reduce costs. So when you're looking at a VMS software, are there initial fees and then yearly maintenance fees? If you want to add or remove a camera or replace a camera, how does that work? Do you have to pay a fee if your initial license has run out? Does the VMS platform support open platform or third-party manufacturers using typically the ONVIF standard? Do you have to pay extra for that? And what level of integration is there? Because the last thing you want is to deploy a system and then down the road have to add a camera to find out that the version of the software that you're running doesn't support that and have to forklift and upgrade to a new system when your system isn't that old. So always want to look for how to leverage what you have or what you're planning on implementing to make sure that it will meet your needs for many years to come. Mobile apps are very popular nowadays. Often they're free. They're included with the software that you have. But so are there costs for the app or for licensing? And what level of features do you have? If the app doesn't do what you want to do you then have to buy a third-party app and then deploy that to lots and lots of clients? And then finally, for your end-to-end solution, are there costs for firmware updates, for software updates down the road? You want to have a nice long lifespan of your products and make sure that you will have proper support for years to come without having to pay out every time you want to do an update. So one common trend nowadays for reducing costs is to have an IP kit, have a surveillance system in a box ready to go. Typically, they'll include things like the cameras, an NVR. The NVR will often have the PoE, the network switch with the power built in. I'll cover that more in a moment. And some of them also include the network cables in there ready to go. So that way you can take this box, go do a nice small installation very quickly and easily. And the way that that can really save on costs, number one, you know everything's going to work together. You don't have to worry about one brand camera with another brand recorder or video platform. And because the NVR is bundled with your network switch, it's one less piece of equipment to have to buy, and there can be additional cost savings because it's all bundled together in that one box. You also don't need to worry about buying the right type of power supply or low voltage cabling. No software or licenses are usually needed or downloads. It's all in that box ready to go. So you're saving on the hardware, but also during your installation, your labor, because it's all right there, quick and easy. Next, as I alluded to, is PoE NVRs. These have been out for a couple of years. What they are, it's a traditional network video recorder, but on the back of it, it has a built-in network switch, and that network switch has your power over Ethernet in it, so it can deliver power to your cameras from a single cable. Oops. There we go. And you don't need to have additional equipment in the field for that. So significant cost savings. You also save on space. So sometimes in certain applications like retail, space is very limited at a premium, and this is all in one compact box. And typically they're easy to set up. They're typically plug and play. They will discover the cameras. They will give the cameras addresses, and all the programming and configuring is done right through the recorder. So again, you're saving your time on your labor during your installation. Another thing to think about when you're talking about the IP cameras is what we call the SoC, or the system on a chip. A lot of cameras typically have a DSP, a digital signal processor, but nowadays we're seeing more and more cameras that are moving to a full-fledged SoC that does much more than just process an image. It's not just doing, brightness and contrast and encoding the video. They're doing a whole lot of other advanced manipulations, such as multi-streaming, providing multiple codecs, or cropping, picture-in-picture, lots of neat things. We'll talk about some of those in a few minutes of how that can help save you on bandwidth and storage costs as well. But again, typically a lower cost camera that may not have all those features, just has a typical traditional digital signal processor, you may save on some costs for a lower priced camera, but it may not provide the return with some of the other functionality that a higher end SoC can handle. And like I mentioned earlier, the newer processors, the newer SoCs can handle providing an app ecosystem where we can load applications to do additional things. We'll get to that shortly. And the last thing to mention about the processor on the camera is all too often we've heard in this industry where you ask, hey, can the camera do this or can it do that? Can we add a functionality to a new version? And so often we've heard, oh, the processor on the camera can't handle doing that. There's not enough resources. We don't have enough memory or processing power. And that's where moving away from just a traditional DSP and going to a SoC, a system on a chip, can provide a lot more processing power that gives us more flexibility down the road. So in terms of loading apps, in terms of being able to use this camera as a platform, we've all seen this with our smartphones and our tablets, where everyone wants the value of that device. But we're adding additional value to it by loading these apps. Usually these apps don't come from the manufacturer of the phone or the tablet. And by having that architecture in there, it allows the ecosystem to develop more applications and more things that we want to load on there. So what we're doing is choosing a camera platform, and there are a couple different manufacturers out there doing this, but it's still just getting out of the gate of recognizing that we can do more with our cameras. So we're taking a selection of cameras, we're going further, and we're loading, one second, and sorry, the slides are I'm going out of order here, but we're loading in the ability to add functionality to our cameras. So if we want to do things like license plate recognition, cloud storage, people counting, intrusion detection, business intelligence, enhanced compression options, anything you can think of, we can load an app into the camera to do that. And what that does, some of the strong benefits for that, is that we don't need to have a dedicated server. Often when you want to do things like analytics or business intelligence for a retail store, you have to configure a server and deal with licensing, and it can be very complex, and it's often not cost effective to do it for one or two cameras. So by using a camera that has a platform for adding apps, number one, we're getting the best quality image possible. The camera can send the video stream to the app to process it without it going out of the camera to the network, to a server, and processing that stream. It's being done on the native side, the raw image. Many cameras can run multiple applications at a time. So again, we're not necessarily limited to saying choose one thing the camera can do. And then more importantly, normal camera operations are not affected. So if you have a camera that is recording to an SD card or streaming to an NVR or doing motion detection, wide dynamic range, any of the things that you're used to doing on a day-to-day basis, the camera's still going to do it because that system on a chip is powerful enough to do all of that. Traditionally, when you're running an app on the camera, it's using lower bandwidth than using server-based analytics because I'm not continuously streaming this video to a server to process it. So that's a great benefit, especially if you have a distributed system where you might have a camera that's on a remote location and you don't want to have to pay for continuous bandwidth streaming. There are some hybrid or distributed analytic systems where you do still have a server, and there are some application platforms where they will send what they call metadata to the server to process, but the camera doesn't need to stream the entire video stream. It can send more intelligent data that allows it to be lower bandwidth, saving you on costs, and higher performance. Your analytic server, if you are using one, can now process more cameras. It's often a huge magnitude. Some traditional analytic servers can only handle up to 20 cameras. One of the systems I've worked with, when they go to an app on the edge on the camera, they can now process 200 cameras on that same one server. So you're adding a lot of performance, and you're also maximizing cost because you don't necessarily need such a big, powerful server, and your performance is not going to be dictated by what that server's performance is. And then the other great thing about running an app on the camera is that the camera app can take advantage of the best imaging performance on the camera. It's not just getting a video stream that's already been configured. The app can communicate directly to the DSP or the system on the chip and get the raw video before it's been encoded, and it can even, in fact, manipulate things like the focus or the wide dynamic range or the frame rate or the shutter speed. Any of the features on the camera you can have the app interact with. So if you think about license plate recognition, often having a shutter speed control is very important. And here you can do it without needing lots of dedicated hardware. The next way to greatly reduce cost of ownership is doing an edge recording solution. This is where we put a memory card into a camera. We tell it to record on that camera, and we don't need high bandwidth continuous network transmission. So if I have a camera that's remote at a remote location, I'm not constantly streaming that video, and that can have a huge impact. Even if I have a centralized network, I can reduce my overall impact on the network by not constantly streaming video all the time. There are also times where people are concerned about theft or tampering of network recorders. Here, the video is stored on the SD card, so you don't have an NVR that you have to worry about someone tampering with. Edge storage can also be used in case of a network failure, so if you need to add some more safeguards to your system in case something happens to that NVR, you can have some redundancy for recording purposes. And then, like I mentioned, you also have times where your bandwidth is either intermittent or limited, and edge recording is perfect for that. So I'm going to show you some examples of a network topology and how that's shifting nowadays. The other nice thing about most edge recording solutions, or when you're looking at different solutions, is you want to make sure that you can freely select the profile in the camera or select which video stream, so the resolution, the frame rate, all of that, and be able to schedule that and tell it how to record and when to record on the camera. So this slide here shows a traditional centralized recording system where you have on the bottom right all of your recorders in a data center or in a server room, and I'm sending all of my video through my backbone, through my network infrastructure all the time. As we move away from these traditional models, people want to find ways to save costs on the network infrastructure, on the bandwidth, on the load. A distributed model is where we move the recorders out into the field, not necessarily in a centralized server room. So we're putting less load on the network because we're not sending all this video through the network all the time. That's one way to lower the impact on my network, and possibly, if you're putting in a new infrastructure, not have to buy as large of a capacity of network infrastructure. But then the third way is what I was mentioning for edge recording. This is more of the newer model a lot of places are going to, is where we still have that network infrastructure in place. We still have a command center on the bottom left where I can pull up and view live video or playback, search video, download video from any camera at any time. But I'm only transmitting video through the network if someone is specifically requesting that video. The recording is taking place in the camera. So you have a lot more resiliency on the network in case or resiliency on your recording in case the command center goes down, your network backbone goes down, you're still recording as long as the local network switch is providing power to those cameras. So it's a great way to save on network infrastructure and potentially even your recording platform. Next is analytics. There's a lot of talk in the industry about analytics. People want to try them out. They want to be able to see what they can do. But often there can be a huge burden of licensing of the costs of the analytics. So one thing to look for is many manufacturers out there do provide license-free built-in analytics already in their cameras. And if so, that's a win-win. You can enable, configure analytics without having to buy anything and deal with licensing. They will still work with all the other features in the cameras. So these are some examples of some of the common ones you'll see, things like object appearing or disappearing, virtual line crossing with a direction, entering or exiting an area, tampering detection, face detection, and sound detection. So this is, again, using the power of the SoC, the system on the chip, to do this advanced image processing and often without having to do any licensing. So if that's something that you want to be able to look at, you don't have to buy a specialty or a high-end camera and license it. So that's one thing to keep in mind when looking at different cameras on the market. And when you are deploying analytics, if they are licensed, typically you're going to roll them out in small numbers. You want to do an initial deployment or rollout. You want to test it out. Often before you pay for it, you can get a demo. Make sure it's going to do what you want it to do, without, as opposed to just buying a big system and then finding out there might be some gotchas or caveats. And finally, typically licensing, if you have a licensed analytic solution, they're often licensed yearly. So keep that in mind when allocating funds. And again, that's where if you have built-in analytics that don't require licensing, it can save money year after year after year. In terms of a video management platform or a camera management platform, VMS, CMS out there, a lot of manufacturers will offer, when you're using an end-to-end solution, they'll offer a no-cost platform when you're using their cameras and their recorders. So that's another benefit of looking for an end-to-end manufacturer that offers full solutions. You can have significant cost savings by not having to pay for that Windows software. Often that software is licensed per client. So here you can freely add clients, add the software on desktop machines, and not have to pay per PC. So you can have significant cost savings there. One thing to keep in mind, if you are going to be using third-party cameras, if there's a specialty application that you might need, does the system allow you to use on-BIF cameras, for example? Are there licenses? Are there costs involved if you need to do an advanced function? Or is that something that's already built into the software? So that can save, I've seen times where some manufacturers, it's thousands of dollars just for software alone, for a client software, whereas if you look at your needs, being able to save a bundle by using the included video management platform with the solution. Next is talking about IR solutions. A lot of people are used to using infrared illumination to light up an area. A lot of cameras nowadays have built-in IR LEDs. That eliminates the need for external illuminators. External illuminators typically need additional cabling runs. They need additional power supplies, which all adds to the cost of your system. Even when you're doing things like perimeters of a facility, parking lots, or needing to look at over long distances, I'll show you there are lots of solutions out there. Just look at what your needs are and make sure you choose products that meet those needs, and then you don't have to retrofit and add costly add-ons to that. So if you have long distances you need to cover, you want to look at the specs of the camera to look at the distance rating and the power that the infrared illuminators can achieve. A lot of dome cameras out there have IR lighting, but often those IR lights are not, in the domes, are often not as strong as a bullet-style camera that you see pictured there. The nice thing with a bullet camera is they usually have a flat piece of glass, which will cause there to be less reflections from a curved dome. And that can significantly increase the usability and the performance that the camera can achieve. And then also the last bullet there, a lot of cameras will have a baffle valve, some way to separate the IR lighting from the lens so that light doesn't bleed into the lens and ruin the image. So those are some things to look at if covering long distances. And then the last thing here is there are some specialty products out there designed specifically for very long distances. Many cameras simply put lots of more and more IR LEDs into the camera package to try to cover a longer range. Some products out there will have different banks of LEDs that have different power output, so they'll turn them on and off dynamically depending on if you're looking at something that's close by or far away. There is a different approach out there that's somewhat unique in the market where they put an IR LED, or in this case there's two of them, but they put a lens over them. And as the camera is focusing the imager, the IR lights get focused as well. And one of the solutions out there allows you to have a visible distance of about 150 meters, or about 500 feet. So here's just showing an example. When you zoom out, it floods the area with the IR lighting. When you zoom in, it's going to focus the beams of the IR. And the really neat thing here is you're not flooding the entire area with dozens of high-powered, costly IR floodlights. You can do it in the camera, and the camera's doing it more intelligently, and that's significantly saving on cost. If you're in a parking lot or a perimeter, you often might have to trench that parking lot or that perimeter, and that gets very, very costly very quickly. So having an intelligent solution like this allows you to significantly save on the costs there. And this is just showing another example of how that the lens physically works to adjust that IR, the beam spread on that camera mechanism there. So it's a really unique solution, a neat way to solve the problem of covering a large area when you have darkness and want to light that up. The next series of things I want to talk about is smart bandwidth usage. So H.264 compression for video has been around for quite a few years now, and it's great. But not all H.264 cameras are created equally, and these are some things you can look at by talking to different manufacturers, looking at the product specifications to see what they're capable of doing. There's different profiles in H.264. This is just showing 4 of the common profiles: baseline, main, extended, and high profile. But there's different profiles out there, and the different profiles include different tool sets which will affect the quality and the bandwidth requirements. So when comparing 2 cameras, they might say they're the same resolution, they're both H.264, but based on that profile, you could have significant changes in the bandwidth and storage requirements. So I'm going to show you a couple slides here. I'm not going to delve too much into it, but these slides will be made available afterwards, so if anyone wants to look up what the more detail of these things are. So you'll see on the right-hand side is the high profile, and it does a lot more of these tools that you'll see going down this list, things like the deblocking filter, the 8x8 digital transform, quantization matrix, and CABAC. Each one of those tools use more processing power in the camera, but in turn processes the image more, gives you lower bandwidth, lower storage, but yet a higher quality picture. So it's the best of the best case scenario there. And here's just a couple pictures showing what some of those different tools do. Again, they get a little complex, but just to show you that if you have a lower profile, the camera with a lower profile H.264, they're not doing some of these really cool things. And some of these were specifically designed to overcome some of the challenges that MPEG-4 video had. But then when they implemented H.264, not everyone could have the processing power to do it, so they made some of these tools optional or put them in the higher profiles and left them out of the lower profiles. There's a feature called Entropy Encoding. Some cameras, you'll see that in the menus where you can click and choose which version or which type of entropy encoding to do. It provided about 20% increase in performance over MPEG-2 or MPEG-4 by adding what's called the in-loop deblocking filter, and I'll show you that in a second. And it's really cool. The video on the left looks very blocky, and I know on the webinar here you can't always see all the details, but it looks very blocky. That's what we've been used to for years with MPEG-4 video. H.264, they required you to put in this deblocking filter in most of the profiles, and it would process the image over and over again, reducing those harsh, jagged edges that we've gotten used to seeing on streaming video. So it gets rid of a lot of those artifacts that no one likes to see. Another thing that can really help reduce the cost of your bandwidth, a lot of people don't talk about, is the iframe interval, or sometimes it's called the GOV, the group of videos, or GOP, group of pictures. There's a amount of time between an iframe. An iframe is like a snapshot in a H.264 video. In some systems, that iframe is happening too often, and you get this breathing effect, and it takes up a lot more bandwidth, and it causes spikes on your system. Your video card and your PC, your network is all getting hammered with too much video. So having cameras that allow you to greatly adjust the iframe interval or the GOV length can help smooth out that video in terms of the bit rate, so your network switches and your PC, your video card, isn't getting taxed as hard and as often, and solve those breathing artifacts that can make a picture very just difficult to look at for long periods of time. So that's a common way to lower your total bandwidth and storage with whichever system you have, as long as there is that capability to make those changes. I mentioned about the entropy encoding. This is just showing the two different types out there. One of them is called CAVLC, Context-Based Adaptive VLC, and that uses like a Morse code type of pattern substitution, which was quick and easy to do. The higher processing entropy encoding, CABAC, used a lot more processing power on the camera side, but it allows you to have a higher image quality. So you'll see the screenshot here showing how some cameras allow you to choose which type of entropy encoding to use, allowing your system to be more efficient and more effective. So some of those tools that you get from the H.264 profiles, some of them, certain manufacturer cameras, allow you to directly get into there and choose which tools not to use. Now, moving on into the future, H.265, a couple manufacturers have started making announcements and starting to release them. That's going to become more and more prevalent the next couple of months, the next year, more cameras coming out with that. H.265 promises about a 50% bandwidth reduction while providing even higher quality picture. And people are starting to move from full HD to 4K resolution to 8K resolution. That's really not going to be possible to be cost-effective to deploy in larger systems without going to H.265. Now, when choosing an H.265 product or solution, you often want to look for a system that is backwards compatible Some cameras out there will still have H.264 to give you an easy migration path. That way, if you have integration with other parts and pieces, whether it's video door intercoms or different types of systems out there, or legacy video management platforms that you've already paid for or licensed, will these newer cameras allow you to still keep using them without having to just forklift and put in a brand new system? So that's really important to keep in mind when looking at H.265. Other things about bandwidth usage is some systems, some cameras out there, when you go look at nighttime, low light images, what is the real life bandwidth usage? How does that compare to daytime? If your daytime image is nice and low bandwidth, but then at nighttime it spikes, there's too much noise in the image, any bandwidth calculations you did might be thrown out the window. So it's important to look at the performance of a camera at nighttime as well to make sure that you're validating your calculations for bandwidth and storage for 24/7 use. And that way you can minimize having to pay extra for lots of additional storage that you might not have needed with a different type of camera. Another way to use your storage and bandwidth more intelligently, things like analytics, like we talked about, and also motion detection. Am I streaming video through the network all the time, or am I sending it on demand when something happens? And some more intelligent systems allow you to specify detection areas or masking areas, where to look, where not to look. And this is showing you an example where you can specify a minimum and a maximum size. So that way, if I want to look for people walking by, but not cars and not an animal walking by, I can finely tune my camera so that it's not recording on motion every single time anything happens in the scene, wasting my bandwidth, or more importantly, wasting my storage, filling up my storage, and not meeting the requirements that I might need for retention. Another way to help, I mentioned about the low light, to make sure that your low light images are not consuming too much bandwidth is noise reduction. Many cameras out there have a variety of technologies for noise reduction, and you can sometimes adjust the level of noise reduction. And you can see the picture on the left looks a lot cleaner than the picture on the right. That's just a snapshot, but if you looked at the video, you'd see the noise rippling through on the right, and that can, again, considerably consume a lot of bandwidth, eating up your storage. Another intelligent feature that people are trying to use, depending on your scene that you're capturing. So here's a roadway where I'm interested in the cars driving on the road, but I don't care so much about the top part of the image. You can do a region of interest encoding where you specify, you draw a box on the screen, you tell it that's your region of interest, and it will retain the same picture quality that the camera can output there. But the excluded area that you're not interested in, it gets compressed higher, so you're lowering your storage needs and your bandwidth requirements, while still getting the visual acuity that you want, that you require for the target areas. So that's one really neat way on a camera that has a more advanced system on a chip to process that image. And this is just a use case here where you can see in a subway station where they had specific areas they wanted to capture the highest quality. There's wasted areas, there's the ceiling or whatnot, that they don't need the highest resolution. In this way, we're able to still capture the whole image, but specify the area that I want to focus my bandwidth or focus my storage on. Another thing that's common is having cameras with lots of different profiles or video streams in them. But more and more cameras now are providing more options, more flexibility to have lots of different streams. Well, why do I care? Why do I need that? Can't I just send one stream and use that for everything? What I can do is I can fine-tune one profile. So, for example, the 1080p profile at 15 frames per second, that might go to my recording platform. But if I'm viewing my video live, I don't always need the highest resolution, but I often want a smooth-looking video, higher frame rate. And then if you have mobile access, whether it's on-site or off-site, you might want to fine-tune that of what resolution, what frame rate, what codec works best based on your wireless infrastructure or your internet connections, things like that. So people are starting to use more and more profiles on the camera. So look for cameras that have that flexibility. Same thing for SD card recording, the edge recording we talked about, being able to choose that profile for that, as opposed to if you had a camera that was much more limited in the number of profiles. If you wanted to view it remotely through the internet, you might be forced to view a high resolution, high bandwidth, and that'll be eating up your internet connection, that'll be eating up your cellular data, and some phones out there might not be able to handle that higher resolution video. So having multiple profiles can impact lots of different pieces there. Another way to process an image is what they call cropping or multi-cropping, where you can specify the region of interest. Here you can have multiple regions of interest, and you can create kind of a virtual camera from each stream. Each one of those profiles can be targeted on a specific part of the screen. So that way you can stream specific areas. So if you have an operator who's supposed to be watching a specific area of the screen, great, they're viewing that. If you have someone who is viewing remotely on the internet, on their cell phone, they don't have to view the whole megapixel image. They can, again, save bandwidth, save storage costs by only streaming, by only viewing certain pieces of the image that may pertain to them by using the cropping. Another thing that usually is not related to the image of the camera, or not directly, is focusing the camera. Usually that's during installation. There's a feature, we call it simple focus. There's different names out there, where the camera finds the best focus position. Don't overlook the cost savings and the return on investment for the long-term life of a system by having cameras that can automatically focus themselves. During installation, if you have a large system, being able to remotely focus them and not have to fiddle with each camera, and then if there's maintenance down the road, if a camera gets impacted or gets adjusted or whatnot, being able to remotely focus them very quickly and not have to spend time trying to find the best focus. That can significantly save time. I've seen cases where you have systems of hundreds of cameras. Being able to click a button and refocus all your cameras quickly and easily is a huge cost saver. And also for installation, having cameras that either directly mount to a gang box or have a plate included, you don't need to buy additional parts and pieces to mount it to a standard gang box. Some sites, you have a division of labor, right? You might have a union person who has to install one part of the camera, and then you have the electrician, or you have the integrator does another piece. Being able to have a gang box mounted and easily mount a camera to that gang box without having to buy additional parts can really save time during your installation as well. Power over Ethernet is pretty standard now. Everyone wants to use it. Just that helps save costs by using the infrastructure you already have, not running additional cabling. The one thing to keep in mind is, what does the camera require in terms of how much power? Is it PoE or PoE plus? And also, are you using switches or injectors? Are you using 100 megabit or gigabit, and not necessarily overbuying and buying the specification of what the cameras require so that you don't overpay for features you don't need or power you don't need on your network infrastructure. And then the final way to save on cost that I'll talk about today is being able to deploy fewer cameras. By using high zoom, pan tilt zoom cameras, being able to zoom in as needed, using higher resolution cameras. Here's an image. Can't really see all the detail because it's such a small little picture on the webinar, but it's showing a 4K camera, which is also, this camera is a 12 megapixel camera, using higher resolution cameras to cover a wider area. typically using ultra-wide-angle lenses or even fisheye cameras, having a room that you need to cover, instead of having to put 3 or 4 or 5 cameras, putting 1 or 2 higher resolution cameras. But you also then utilize fewer channels on your NVR. If you're using a VMS that you are licensing and paying per camera, you're now having less licenses you have to pay for. And then finally, with having fewer cameras deployed, you have less cable runs to have to run, less mounts or housings to pay for and install and mount, and then less network ports that you need to have available on your network. So there's a lot of ways to save costs by deploying fewer cameras and also looking at your needs of what your security needs are and having cameras to address those needs specifically. And this is just showing a small retail store. By putting a fisheye camera in the middle, you can get away with having only 1 or 2 cameras inside that store, and potentially even 1 fisheye camera outside, and not needing 8 or 10 cameras in that store. And it allows you to have situational awareness of that space. And then lastly, a lot of manufacturers, Samsung, we have a lot of different design tools available to help you design a system quickly and efficiently and getting the right parts and pieces and being able to do a lot of self-service of designing it properly yourself without having to waste a lot of time doing it and redoing it. So I will turn that back over. I thank everyone for their time, and I think we'll move over to the Q&A portion.
Thank you, Aaron. Great job. At this time, we'd like to address some questions that have been submitted. As a reminder, you can submit a question using the Q&A box at the bottom of your screen. If you don't get to your question, a Graybar representative will follow up with you after the presentation. So first question, Aaron, do you see any issues using PoE NVRs on an existing network, or should they be used for standalone systems only?
Thank you. That's a great question. A lot of the PoE NVRs, when they were designed to be small, cost-effective, standalone systems. Many of them can be integrated into a larger system. That's just something important to look at when choosing a PoE NVR that doesn't have the additional network ports. Doesn't allow you to uplink it to your existing platform, your existing network, and have multiple PoE NVRs as opposed to just a standalone system that you may outgrow. So you want to make sure it can survive the lifespan that you have for your system. So yes, so many of them can be done that way.
Thank you. Another one, regarding apps on the edge, can they perform as well as a dedicated server solution, and how is licensing handled?
Right. So many of the application providers out there have been in that space for many, many years, doing analytics and license plate recognition and cloud storage, all those different types of applications. So they have the knowledge to make it the best in breed, to make it the best possible solution, but you're often saving on the cost because you're not buying and deploying an entire server and managing a server. Licensing is done differently for each application out there. Some of them are a one-time fee. Many of them are yearly licenses, so each one will vary. But the performance that they can do often will rival, if not outperform, a dedicated server-based solution. So that can help save lots of cost.
Okay. With edge recording, do you lose any features? Can you still use a VMS interface? And how do you search for video?
Okay. Typically, when you're using edge storage, you're not going to lose any features. You're going to still have the same resolution, the quality, everything that you've selected in the camera. Your camera will still do your motion detection and all the other things it was doing. It's important to look when you're looking at either a VMS or a CMS, your software, does it support pulling back that edge recording? Many or most of them do. There are some new ONVIF profiles that are out there, ONVIF Profile G, designed specifically for edge storage so that it will better interoperate with different platforms. But a good edge storage solution, you're going to use your nice Windows-based software. You're going to search on your timeline. You're going to search playback and download video, just like any other DVR, NVR, VMS. You typically don't have to go and physically remove an SD card or have to go to a web page and review it. You can do it through your nice Windows software.
Thank you. Well, we're about out of time at this point. If we didn't get to your question, a Graybar representative will follow up with you after the presentation. As a reminder, this presentation will be archived on the Graybar.com website. Again, thank you for your time today, and we hope you will join us again for an upcoming G2 Talk.